Hey everybody, and welcome back. We're now up to part 9, and where some real work's going to happen. We're going to turn some LEDs on and off, and we're going to write the assembly language routine that sets our LEDs to whatever we get told through the parameters of the function. So let's go back to Visual Studio Code. This is the function we want to write is setLED. So let's go create our setLED.s file. So setLED.S, recall the capital S that we go through. And so in this, we're essentially going to do a lot of the same work and the same setup that we did for the setup GPIO. And let's get going with that. So again, we're going to do a .section.text because we're writing code. We're going to align 2 to the 2. And then we're going to, in this case, do a global of setLED because that's the name of our function, and that's what we want the compiler and linker to be able to find. Now we're going to include again our memory map. So memory map, whoops, I need to put some quotations there. Memory map underscore map dot inc. And then we're also going to include our GPIO.inc because we're going to need all of that same information for this. Now I'm going to create a couple of what would be defines just to keep the code a little bit nicer. So I'm going to do a .equ, again, assembler directive. This is the equivalent to a define statement called no error. And the no error is going to be a value of 0. And of course, the counter to that is I'm going to have a value called error, which we're going to have a value of 1. And then the other one I'm going to do is a value of LED on, so that if the LED is on, it's also a 0x1. And so let me do a little bit of tabbing here. Whoops. And voila. So if you recall, I said that one of the things I wanted to do with this function, even though it's, I'll say, not overly practical, is to show you how to return an error code from an assembly language function back to a C parent. Now, one of the things that, depending on your background and where you come from and what kind of assembly language code you've done, etc., is you might expect that the parameters that a C function sends you would be pushed onto the stack, and then inside of your assembly function, you would pop those from the stack. RISC V is a little bit different because if it's able to use registers, it'll use registers in order to send you your parameters. So in our case, if we go back to our superblink.c, we've got two parameters. We've got color and state. And it turns out that the color value is going to be sent to us in register A0, and this is going to be sent to us in register A1. And there's a couple of ways for you to figure out how to do that. One is that RISC V reader book I keep talking about. I know I'm a broken record on that one. A lot of that information about which register is used for what is documented in there. And the other thing is to just debug through the code. So write a function, have it go through, and then look at the registers and see where your values are. And that's another way to kind of figure it out. So, but just for completeness here, I'm just going to write some documentation, some comments that says, hey, which LED to set comes into register A0, and then the desired on-off state comes into register A1. So that way, if somebody reads the code, they'll be able to quickly figure out what's going on. Let's write our label because this is now our entry point for our function. And if you recall, now we're going to do our proper setup of the stack environment and allocate our stack frames. We're going to do the exact same thing. So we're going to add immediate stack pointer. We're going to add to our stack pointer a value of -16 because we go backwards, the stack pushes up. And then we're going to store word, all right, and we're going to store that our return address. Whoops, I pushed the wrong button here, apologies for that. We're going to push our return address into an offset of 12 into the stack pointer. So now we've set up, and just to be complete here, I should put some comment, allocate the stack frame, and then over here save our return address onto the stack. All right, so now that we've got that set up, we can actually start doing some real work. And so the initial work we want to do is get some values in that are common. So no matter if you're setting the LED on or off, there's a couple of things you need in common. So one of the things is your GPIO control address. So let's load immediate into our temporary register 0 the value of our GPIO control address. So it doesn't matter if we're writing an on or an off, we need to know where the GPIO address is. So load the GPIO address. And then what we want to do is get the value of the pins that are currently set. So let me write this in, and then I'll explain a little bit more of what I'm doing. So I'm loading temper1 GPIO output val T0, and then get the current value of the pins. Well, if we really think about our function, and let's say when somebody calls a function, they say set the green LED on. Well, what you don't want to do is mess up any of the other pins. So if the blue and the green are already on, you don't want to have the fact that you set the green on to turn the red and the blue off. And so you want to find out what the current state of the GPIO environment is. And if you recall, when we set up our GPIO Inc., one of the things that we said was the output val. And so that is the current values and how the GPIO is currently set up. And so that's why we want to get that value, and that way we'll be able to do a little bit of bit manipulation and ensure that we only alter the bit for which we want to make a difference. All right, so we know that register A1 has the desired on-off state, and so let's do a branch that says if we want an off state, go to a different place, and if we want an on state, then we'll just kind of keep going. So we're going to say branch if equal to 0. So it's pretty intuitive, right? Branch if equal to 0. So that means if register A1 is set to 0, which is a requested of an off state, then that A1, then go to a place called LED off, because that's what we're going to go do, is go turn off. So then our comment here is very simple. Branch off to turn off LED if A1 requests it. All right, so that's basically saying, okay, we've got an off request, we're going to branch. But if we don't have an off request, then what we want to do is do a we actually want to turn on the LED. And so what we're going to do is load into our another temporary register. So we're going to take temporary register 2 now, because that's where we're to, and we're going to do an LED on. And if we look up here, we recall LED on means that we have a value of 1. Okay, so that's basically what we want to do. So our comment's pretty simple. Load up on or the value of 1 into our temp register. And then what we want to do is to basically branch off to turn on the LED if A1 requests to on. So now we're going to say branch if equal. So in other words, if we got a request for an on, so we're basically saying, okay, let's put on an on value. And now let's say branch if equal A1 and T2. So if these two values are equal, then I want you to branch off to a function called LED on. And so, whoop, I got a unfortunate auto capitalization here. LED on, so we'll stay here. Branch if on requested. All right, so basically what we've got now is a LED off was requested, an LED on was requested. And so if we basically didn't get any of those two things, then we have the error code, where we have that error that I mentioned. So if we get to this point here, then we were sent a bad status code. So somebody didn't say LED on or LED off, they sent us a bogus code. So what we're going to do here is say load immediate into A0 the value of error. All right, so it turns out that just like we don't use the stack to receive some of our initial values from C function, we're also going to send our error code back through register A0. So that's why I'm loading register A0. I'm loading the value of error, which is a value of 1, into A0, so that basically that's the value I'm going to return. So we can put a comment here that says we got a bad status request, return an error. And then jump to exit. So we're going to have another area that we're going to go do an exit. So this basically sets us up so we have now something that's very clean. We have our initial GPIO addresses. We've got where the current state of the LEDs. We know if we've been asked to do an off or an on, or if it's been a bogus. So now let's go through and deal with each of those conditions. Let's start with turning an LED on. So one of the things we want to do is create the function. All right, so let's do an XOR T1, T1, A0. So why am I doing that? Remember I said that we only want to impact the LED that we've been asked to set or unset. Right? We don't want to impact any of the other pins. So essentially by doing an XOR, I'm only going to change the status of the pin. So of the pin that's being requested. So do an XOR to only change the value of the requested LED. So now we have the XOR done. Now we can actually write our value to the GPIO register. So we're going to store that word, the T1 register that now has the only thing we want to change, to the GPIO output value. And we want the offset of T0, and if you recall, in T0 is where our control address. So it's control address plus the output value, and that's essentially where we're writing or storing this word T1, right? So hopefully that's starting to become a little bit more visible as I do it a few more times. So now we basically say write the new output value to the GPIO output. All right, so we've got that LED on, and because we got to here, we know that we have no error. And so because we have no error, we want to make sure that we load into A0 a no error value. So we say we have no error, and then we're going to jump to our exit because we're all done. So we've set our LED to on, we had no error, and then we can jump. Now some of you might say, hey, didn't you tell us that the X0 register is always 0? So why didn't you just say load into A0 X0? And that would have been an option. I would have used another instruction called move, and I would have moved the contents of one register to another. So up to you if you want to do that. But I prefer doing it this way because it's a little bit more English in the code, and it makes the code a little bit more readable. So now that we've got our LED on set, let's go set our LED off. Now in LED off, we have to do the an extra step in here that we want to invert all of the bits so that only the bit we're turning off is set to 0, right? So if there's any bit that's already on, that's already 1, we don't want to touch that. We only want to touch a bit, the bit that we've been asked to touch. So in this case, we're going to XOR, and we're going to do again A0, A0, and we're going to do a 0x And we're going to do 1, 2, 3, 4, 5, 6, 7, 8. So we're going to have basically an XOR with all ones, and that'll just invert everything. And so that way only the bit we're trying to change is going to be set to 0. So that's why we're doing that. And so we basically put a comment to explain that. So invert everything so that all bits are 1 except the LED we're turning off. And so now we can basically AND these values together. So T1 comma T1 comma A0. And this will, if we say and A0 and T1 to get the LED we want to turn off. So when we were turning on the LED, all we had to do was do this XOR to only change the value. Here we had to go through in the off condition an inversion process and then ANDing this stuff together so that we're only impacting the bit that we want to go through. This should be familiar to you, obviously, if you're familiar with bit manipulation. But now we've accomplished the one, so now we can store that in order to set the bit to the where we want to. So we're going to store our register T1, which has the value, and we're going to, again, put that in the same place, our GPIO output val, and then relative to T0. So write the new output value to that. Register. All right, so we've essentially got now our LED on, our LED off condition, and again here we did not get an error. So we basically want to set our A0 to no error, and we could here say jump to exit. But the very next thing we're going to do is write our exit routine. So it would add a useless instruction to say jump to exit when the next instruction is exit. So I'm actually not going to do that. So I'm just going to leave it like this. And then in the exit, we essentially want to unwind everything. So here's the really cool thing. Notice that I loaded my error into A0. I've loaded no error into A0. I've loaded no error to A0. So I'm done. There's nothing else I need to do in order to send that return value to the calling function. All I have to do is unwind my stack, set up or restore my return address in case it had changed, unwind my stack, and go back to where we came from. So let's go through the standard procedure of load word into our return address and get it back from where we put it into the stack. And so we have that value. So here we can comment this and say restore our return address and then unwind our stack. So we're going to add immediate stack pointer value of 16. So that basically says take 16, add it to the stack pointer, store it back into the stack pointer. So that's how the add immediate work, and we're deallocating our stack frame here. And then the final thing we do is that we return back to our caller. And so that's it. We have now written our second assembly language function. This is where we do the bulk of the work that our super blink does. It either turns an LED on or an LED off. We've taken very good care to make sure that we are only impacting the bit that was requested and we're not touching any of the other bits in the GPIO. And so by doing that, if any of the bits were already set by some other routine or by something else, we're not impacting that. We're only impacting the thing that we were specifically requested from doing. You're getting exposure here to a few more of the RISC V instructions. RISC V only has about 60 instructions, so they're very easy to remember, and so this you'll start getting second nature. The RISC V reader has all of the instructions, all very clearly documented, or you can go to the risc5.org website and download the instruction set manual and get all of the instructions from there. At the end of the video series, I'll do a little summary of which instructions that we used. But you're also seeing some assembly language pseudo functions that need to get done, like setting up our code, our alignment, setting up our values so that the compiler can find it. You've got the assembly language equivalent to defines that you could use. So there's a lot going through here that you've learned in terms of how to set up a function and how to return from a function. Here we're going to see how we return from an error. And as you guessed it, our next step in the process now is to actually debug through the code and see if our LEDs actually turn on and off as expected, and even test if we can get an error code back. So let's get to that next step.